Hi, welcome to Zona Mechanica. There is an MCQ on torsion. Figure out the margin indicates the weightage of the question, that is 2 marks. A solid shaft of diameter D and length L is fixed at both ends. A torque T0 is applied at a distance L by 4 from the left end as shown in the figure given below. The question is, what is the maximum shear stress developed in the shaft? There are 4 options given. Well, this is the shaft of length L, overall length L, and diameter D, and a torque of T0 applied at L by 4 from the left end. Okay, so clearly there are two segments. Suppose this is segment number 1 and this is 2. Okay, and the torque developed here is T1, and here in segment 2 is T2, and the corresponding shear stress is tau 1 and tau 2 respectively. Okay, so clearly we can say T1 plus T2 is equal to T0, right? Since this is a parallel connection, this is equation number 1. From the torsion formula, T by J is equal to G theta by L. All the symbols are bearing usual meanings. We can say that this J is fixed since the D is fixed. Okay, that is the diameter throughout the length is same, that is the cross section is uniform cross section. Okay, so J is a constant and G, the modulus of rigidity, is constant, the homogeneous material. Okay, and theta here is same for both the segments since it's a parallel connection, so theta also constant. So from here we can say T is proportional to 1 by L, right? Therefore we can say T1 L1 is equal to T2 L2, which implies T1 into L by 4 is equal to T2 into 3L by 4, right? So from here we can say that T1 is equal to 3T2. Therefore clearly we can say T1 is greater than T2, right? Since okay, now from the relation T by J is equal to tau by R, so we can say this tau is directly proportional to T, since J is fixed constant and R is also constant, so tau is directly proportional to T. So whichever T is greater, the corresponding tau is greater, that is the shear stress is greater. So the tau 1 will be the maximum shear stress corresponding to T1, right? Since T1 is greater than T2. Okay, so from here we have T1 by J is pi by 32 d to the power 4 is equal to tau max by d by 2, right? Which implies T1, let us get the T1 from here. T1 plus T2, T2 is T1 by 3, right, is equal to T0, that is 4T1 by 3 is equal to T0. Therefore T1 is equal to 3T0 by 4, right? So from here tau max will be equal to T1 by pi into d cube into 16, right? Which implies tau max is equal to T1 is 3T0 by 4 into 16 by pi d cube, which is equal to 4, that is 12 T0 by pi into d cube. Clearly, this is the maximum torque developed in the shaft, that is at the left hand segment. So clearly it's matching with option B. So option B is the correct answer.